Okay, so today we want to look at trig functions and their derivatives. From the warm-up, we already actually did this one. It looked a little different, but if we want to find the derivative of the tangent of x, well, I don't know anything about the tangent of x, but I know that it is equivalent to the sine of x divided by the cosine of x. Bless you. So those are two functions that we know the derivative of them, right? So if we have a function that you can take the derivative of, dividing another one you could take the derivative of, that's when you want to use the quotient rule. Okay, so with this one, and remember, if we want to find, so to find the derivative with respect to x of the tangent of x, which is what we're looking for, we're going to find the derivative with respect to x of the sine of x over the cosine of x. So that means we're going to look at a quotient rule. So let's say u, which is our numerator, would be the sine of x, and u prime would be the cosine of x. Just again, derivatives that we know. V, the denominator, is the cosine of x. So v prime, or I guess if we're using differential notation, that'd be du over dx, and then dv over dx. Okay, so again, just to kind of mix the notation up here. So then with this, in order to find this derivative, we know the rule is going to be v and then du dx minus u times dv over dx over v squared. So again, we're going to find our u prime, or du over dx, or v, and our dv over dx. Find our pieces, then we're going to fill them into the formula. Right? So we have to remember our formula. So this will give us v is the cosine of x, du over dx is the cosine of x, minus u is the sine of x, and then dv over dx is negative sine of x, and then we get the denominator, which is cosine squared of x. So we take whatever v was, which was cosine, and we square it, so we get cosine squared x. You either could put the whole cosine x in a parenthesis and square it on the outside, but this is how we're going to tend to write it. So as we look at this, to simplify, well, this is just going to give us cosine squared. Here we're going to get a negative times a negative, so plus, it'll give us sine squared. So cosine squared of x plus sine squared of x over cosine squared of x. Now, hopefully you remember from trig, if nothing else in terms of identities, we know that cosine squared plus sine squared is our fundamental Pythagorean identity. It's just equal to 1, correct? So this gives us 1 over the cosine squared of x, which generally, instead of writing that, we go ahead and that is equivalent to the secant squared of x. So the derivative with respect to x of the tangent of x is the secant squared of x. Right? So just another rule that we know. Another one. So let's take a minute and let's try to find the derivative of the cotangent of x. Okay, so you're going to use the same process. Hopefully you remember it's not sine over cosine, but cosine over sine. So give that a minute and see how that goes. Okay, so for our derivative of cotangent x, again, we're going to take advantage of the fact that that is the cosine of x divided by the sine of x. Okay, so when we do that, we're going to do v du dx minus u dv dx over v squared. So probably still beneficial to write our steps out here. So as we look at this, We know that u is going to be our cosine function, correct? Let's get rid of this one because that's not correct, is it? So for this one, we had that u is the cosine of x. So du dx is negative sine x. And then v would be the denominator, which is the sine of x. So then dv over dx equals the cosine of x. And again, it's still kind of similar to where we did the product rule, where you know you're going to end up at a derivative times the original and a derivative times the other. You know you're going to get those together, but here order matters because we're doing a quotient. So we're going to get v, which is the sine of x, times du dx, which is negative sine x, and then minus u, which is cosine x, times cosine x, which is dv over dx. And this will all be over sine squared x. So at this point in the numerator, we get negative sine squared x minus cosine squared x over sine squared x, which once you factor a negative 1 out of the top, hopefully you'll recognize that's our Pythagorean identity. So you'll get negative sine squared x plus cosine squared x over the sine squared x. And really, that's the one big identity that we really want to be familiar with. So then that just becomes negative 1 over the sine squared of x. Right? Instead of writing it that way, we're going to say that is the negative cosecant squared of x. So negative cosecant squared of x. Okay, so that's our second one. We already knew sine and cosine. So the next thing we want to do is we want to find the derivative of, we just introduced secant and cosecant, right? So we're probably going to want to think about what those are. Let's go ahead and do the derivative of y equals secant of x. Right. So any guesses on how we're going to rewrite secant to do this? 1 over cosine, right? So we're going to think of it as y equals 1 over the cosine of x. Now this is a case where if it were like an x to the 4th, I'd tell you to move it to the numerator, but here that's not going to work because we don't know what cosine that would be a mess. That's not. We don't have the functions or the notation for that. So here, let's go ahead and apply the quotient rule to that, and let's see what we get. So let's go ahead and look at our secant function here. We have the derivative with respect to x of the secant of x. Again, we know that we were going to say that u is equal to 1 and u prime is equal to 0, or du over dx if you want to do it that way. And then v is the cosine of x, so dv over dx is negative sine of x. Okay, so we have that. And then from here, I'm just going to write my rule again. So v du over dx minus u dv over dx over v squared. This one, the simplification is a little bit goofy, like maybe unexpected, but works out pretty nicely. So here we get the cosine of x times 0, I like that, minus 1 times negative sine of x over cosine squared of x. We all get there? Okay, so with this, obviously this just goes away, and this is a negative times a negative, right? So what you'll see here is the sine of x over the cosine squared of x, which is not wrong, but you never see it that way. For whatever reason, you always see this one as, it's kind of rewritten as the sine of x, well, no, it's actually written, let's make it look right, as 1 over the cosine of x times the sine of x over the cosine of x. So this will not kind of make sense why I split it this way till you see the answer, but do you agree that this is the same here? 1 times sine is sine, cosine times cosine is cosine squared. And then with this, 1 over the cosine of x is the secant of x. And then the sine of x over the cosine of x is the tangent of x. So that's typically how you'll see it written. The derivative with respect to x of the secant of x is secant x times tangent x. And I've never really seen this way used. I'm sure there's a good reason that we use this one instead, but it's kind of eluded me as we speak about it. Okay, so if you look at this, the only one that we have left here is going to be the derivative with respect to x of the cosecant of x. Should be a parenthesis there. It's going to work basically the same problem again, right? It's just going to flip things around. I can leave you to maybe try that one if you want, or let's see. This would be the same as the derivative with respect to x of 1 over the sine of x. And then we know we're going to take the denominator, sine of x, times the derivative of the top, which is derivative of u, which is 0, minus the numerator times the derivative of the bottom, which is cosine x. And then on bottom, we're going to get sine squared x, which gives us negative cosine x over sine squared x. And we're still going to break it up and write it as a cosecant and a cotangent here. So this is going to be negative 1 over the sine of x times the cosine of x over the sine of x, which gives us negative cosecant x cotangent x for our sixth and final trig derivative. So we get the derivative of cosecant x is negative cosecant x cotangent x. So again, just these are nice things to just practice proving it. If you can do these, you definitely can do the quotient rule, right? And they're not too much crazy distributing stuff going on there. So, but here we have our now we have all 6 trig things here, and you want to memorize each of these, right? So again, some patterns we had. Anything that started off with a co on it, its derivative was negative, like there. Okay, and then this one, so these 3 are all negative. Right, you notice the pattern between tangent and cotangent, hopefully, right? They're reciprocals, their derivatives are reciprocals, and then it's kind of the same idea here as well. And here as well. And no, never mind, not reciprocals. But just kind of get those, work on those. When we quiz on Friday, you'll need to know those. Those are things